All right, so we've got another vector decomposition problem. I've got a vector f. It's pointing upward vertically, and I want to split this into pieces in the e hat 1 and e hat 2 directions defined as such. So according to my recipe, what I do is I take my vector f and form a vector triangle from this thing where f is on the hypotenuse of the triangle. The other two sides of the triangle are parallel to the e hat 1 and e hat 2 directions, and they're arranged in tip-to-tail fashion so that these other two sides add up to f. Let me show exactly what I mean by that. So I'm going to start at the base of f, and I'm going to move outward in the e hat 2 direction, right? Some amounts, and then I'm going to move in the direction of the e hat 1 direction, or something parallel to the e hat 1 direction, like so. And these two these two vectors, this one plus that one, they're arranged in tip-to-tail fashion so that they add up to this vector f. Right, and now I just need to figure out how much in this e hat 2 direction and how much in this e hat 1 direction to make it all work out. And to do that, I'm going to have to identify some angles. Notice that the angle that was given to me, this theta right here, that's the angle of the e hat 1 direction relative to relative to horizontal. So if I just draw a horizontal here, and notice that this side of my vector triangle, that's parallel to the e hat 1 direction. That means that this side, or this angle right in here, has to be the theta, right? That's identified perfectly right there, which means that if we go to the interior of the triangle, and we're going to have to go to the interior of the triangle because it's hard to do trigonometry with these exterior angles. So this interior angle right there, this one's going to have to be 90 degrees minus theta, right? That's because this horizontal and vertical make a right angle, and yeah, it's just obvious, I think, I hope. So there's 90 degrees minus theta, and then let me just point out a little bit of geometry to us really quickly. So let's suppose I construct a triangle that looks like this. And furthermore, we'll say the angle here is alpha. That's alpha, and the angle there we'll call beta. And let's suppose this is a right angle right there. So the sum of the interior angles of a triangle have to add up to 180 degrees. In other words, if I take alpha plus beta plus that 90 degrees that's right here, those three angles have to add up to 180. And if you bring the 90 over, then I got alpha plus beta is equal to 90 degrees. So since this is a right angle right there, these two angles right here have to add up to 90 degrees. So I've got 90 degrees minus theta. This angle has to be theta right there in order to work it out. Aha, so I've identified a theta inside my force triangle, and the rest is pretty straightforward, I think, I hope. So in the e hat 1 direction, this is the e hat 1 on the over here, it's the opposite side from the angle theta, which explains why I have an f sine theta right there, right? Sine is for the opposite over hypotenuse. So here's the magnitude of the hypotenuse. F times sine theta will give me that length right there. The piece in the e hat 2 direction, that's adjacent to the angle theta in this triangle, so that I've got an f cosine theta for that length right there. Remember, f, the scalar f, is the length of the vector f. Let's just double check the signs now. This e hat 1 component, where's that? That's this piece right here. It's going upward and to the left, whereas the e hat 1 basis vector goes down and to the right. So that's why I have this minus sign right here, because this component of my vector f is actually going in the minus e hat 1 direction. And now let's look in the e hat 2 direction. That's this one right here. It's going upward and to the right, whereas e hat 2 goes upward and to the right. These are aligned correctly, so hence I have the plus sign right there. And that's essentially my answer. Let me just take it real quickly. Whoa, I didn't mean to erase it. Well, I can't erase it without destroying it, but there's my equation. Minus f sine theta in the e hat 1 plus f cosine theta in the e hat 2. And that's